here's what. We're going to do transformations, and here's my belief. Swear to God. So I had someone tell me in another class, I thought it was pretty funny. She said, I pretty much got through Algebra 2 tricks because once I learned how to do everything on a graphing calculator, that's all I did. And I'm super opposite of that because I feel like in real life, I need you basically to know how to sketch things. Because here's what. For my juniors who may be taking an SAT or ACT, I am literally buying the points on the next few lessons. Because I can grade your stuff just by eyeballing it, because I know the shape. Like I can be like, nope, that's not right. It's not going in the right direction. Nope, that's not right. It's supposed to be shaped a different way. If we want, there's two ways to graph. There is a sketch that gives me a damn good idea of the shape of it, the direction, what's happening, and then there's precision. And if we want precision, we're going to use technology. But if we want just a damn good idea, we don't want to make a huge T chart. I'm telling you, my daughter did that. It's like one number was wrong. She graphed it, and it was like on a test, she got the whole problem wrong. And you guys are going to get to the point where you're going to be like, hey, you know what? I have a damn good idea what this looks like. And I'm like, close enough, because that's what we want to be able to do. If we want exact answers, then we turn to technology, right? So what we need to do today is make sure we're all on the same page about how graphs move around. We're going to start with our old friend that we haven't seen for a while, especially if you're in Algebra 2. We didn't do much. This guy, absolute value. So here we go. You can write him down here. This is the parent graph. This is our home base, right? Our home base for this dude, it's going to look like this. Look, I'm putting my little thing down because it was a little weird looking. Couldn't really see it. So remember what that dude looks like? He looks like this. He's going to go this way. Oh, I'm actually going to make him look nice. I'm actually going to make him look nice. Oh, wait. Hold on a second there. Okay, here we go. So he's going to look like this. Oh, so fancy. And he's going to go look like this. And here's why he looks like this. Because we can't do negative distance. That's what absolute value means. It doesn't mean sticks. And it doesn't mean everything turns positive. What it means is how many jumps from 0 is something. So when I plug in the number 3, what I'm asking is how many jumps from 0 is 3? And 3 is 3 jumps from 0. And that's why the negative works that way. Because when I plug in -3, what I'm not saying is I'm saying how many jumps from 0 is -3. And you know what? You can't do negative jumps. That's like Ferris Bueller driving backwards, right? So that's why when we do absolute value, we just do the positive y values because it's the distance, right? And you don't really need to know that. You might know that. But here's what your home graph looks like, right? Some things I need you to notice. Number one thing I need you to notice is this. Our vertex right here is going to be at 0, 0, right? That's our home base. And when we're going to, I have notes. You come down here, Jordan. I think I have a note sheet down there. It's just on the floor. Look what happens. He goes up 1 over 1. That's how steep he is. Up 1 over 1, up 1 over 1, up 1 over 1. It's a 1-to-1 correspondence, right? Thank you so much. And there you go. Yes.
Why would you start on 1?
I started on 0, 0.
Why is that?
Because I plug in 0,
Oh.
and I say how many jumps from 0 is 0. 0 jumps away, right? That's my home base. But then once I start going positive, it goes this way, and this one still is going to go positive because it's distance. Okay. Now we're going to mess with him, and we're just going to remind ourselves because it's been a year how to mess with this dude. Are you ready? So here we go. The first thing that we got this dude down here, and here's what. We are going to mess with the inside guts. We're going to mess with the inside guts. Now, sometimes we call these dudes, we don't really call them sticks. They're the absolute value signs. But you know what else they are? They're called grouping symbols. They're trapping things inside of there, kind of like this, right? X plus 2 squared. That's a grouping symbol. That guy's trapped in there. Here's another one. Y equals 2x plus 4. He's trapped up there. Those are called grouping symbols. And anything inside a grouping symbol moves our graph. And I want you to think about it and whisper to your neighbor. It either moves it side to side or it moves it up and down. Do you remember? Whisper to your neighbor what you think it is. Side to side or up and down? Remember? If you said side to side, you are correct. It is horizontal. You're going to write that down. It is called a horizontal shift. Horizontal shift. Now, I know most of your teachers last year did this whole H and K and stuff like that, and I hate that. Here's what I'm going to tell you, because I'm going to teach you the good Mrs. Tarantino way. Here's what, and some other teacher taught me this. We put stuff in grouping symbols because it's naughty, right? It's in timeout because it's trying to trick you. This guy is not going to shift him side to side over 2. That would make sense. But this dude is naughty. He's going to shift him the opposite way, right? Anytime anything is in grouping symbols, it will shift your graph side to side opposite, right? It will shift it opposite. So this guy would do it to the left. So if we had our graph up here, watch this. This is so goofy. So I got my graph up here, and it would be so nice if I could shift this, but watch what I can do. I can just shift the graph. So look, yeah, because I'm an idiot. Yeah, so that's how I do that. He shifts it to this way. The shape doesn't change. I just shift it horizontally. So here's what I want you to remember for the rest of this year. If something's in grouping symbols, it shifts it opposite. It shifts it naughty. So on this one, still in the grouping symbols, it's still horizontal, but this time it's going to go to the right too. It's going to go to the right too. So here would be our regular graph in purple. I'm going to make it dotted, but now I'm going to shift it over to, so it would look like that. Yeah? Nice and easy. You all remember that. So pleased. Okay, so we got side to side. Obviously, we can also do up and down. But here's why. Anything up and down is like that poor brother that like has a naughty brother who gets all the attention, and he's like this other guy. He's the good son, and he's not naughty. He's really straightforward. So he is, what we're going to call him is a vertical shift. But you know what? He's not naughty. He's normal. So it would just on this one be up. If it's positive, it goes up. And if it's negative, it goes down. And what I mean by shift, that doesn't mean it flips. It means it literally just shifts. So check this out. Here's our basic home graph. That's our parent function, right? If I wanted to do the first one, guess what I would do? I would shift it 1, 2. He just goes like that. And if I wanted to do the other one, he shifts it 1, 2, just like that, right? But he's not naughty. Only the guys in timeout are naughty. Are we good so far? Easy. Okay, how about the stuff outside? Does anyone remember what the outside stuff does? Do you remember? We're getting there. That's coming. That's super coming. But at this point, just a number on the outside. Do you remember what it is? It's a stretch and compression. Now, I'm going to write those words down, but I'm going to give you a little bit of acting so you know what this means. And I'm going to give you some ways to think about this. This is what's called a vertical. And you know, this year in pre-calc, we're going to be doing horizontal stretches and compressions. They're a pain in the ass, but we're going to do that in a minute. This is vertical stretch and a vertical compression. And here's what I want you, compression. I want you to imagine this, right? So I want you to imagine that your V has, there's those little feet or something. Like it's like maybe you're even working with like one of those exercise bands, right? So you know those stretchy exercise bands? So you put your foot on the exercise band and you hold it this way. And if I said pull it up higher, chances are what's going to happen when you do that is if you pull it up higher, you're going to go like this. Like it's hard to keep pulling it up like this. So you're going to pull it up like this. Do you see how it gets skinnier when you do that? Because you're stretching it out. So you're taking it like this and you're stretching it up. And it's going to get skinnier. So a vertical stretch makes things skinnier, right? It makes it skinnier because you're taking your little feet and you're stretching them up like that, right? If you've ever done that with a baby, people do that with babies. Another way to think about it is slope. It's like slope, right? So watch what'll happen. This is up 1 over 1, but this dude is like his slope. So watch what happens. Now with 2, that's 2 over 1. I'm going to go up 2 over 1. Up 2 over 1. Look what happens to my line. Do you see what I mean? How it's now getting skinnier. I'm stretching it up, right? So anything over 1 is normal. Anything over 1 gets it skinnier. And guess what happens on the fractions? It's a compression. It's taking your hands on his little feet and you're pushing him down. You're squishing him down. You're making his legs go spread out. So here's what happens. On this one, 1/2 means I go up 1 over 2. Look what happens on this guy. He gets fatter. Do you see what I mean by that? It squishes him down. So normal, compressed, or stretched, normal, compressed. I'm compressing it down. Does that work for everybody? Yeah? And it works like slope. Okay, now do the one that Jordan said, which is one of my favorites, and we're going to add to this on Friday. One of my favorites is the last guy. If I have a negative out front, this dude is my favorite. He is called a reflection over the over the x-axis. And you're like, Miss T, why don't you just call it a reflection? Because in ClickCalc, when you start reflecting it the other way, we're going to be doing some ones that look like this. We're going to go like this. We're going to reflect it this way. Then we're going to reflect it down. We're going to be moving this dude all around. It's kind of crazy. But here's what it does. It takes this dude and it literally just flips him upside down. It reflects it. Take it here, bend it here. Yeah? So our goal is to put it all together. Now, I'm going to be honest. We're going to cheat a little bit today, but when these get harder, doing these in the right order is going to be important. But today, it's not as important. So here we go. You want to turn your paper over. We're going to do a few, and I'm going to give you a couple backwards ones, and we'll call it a day. So here we go. You guys ready to graph? So let's start here. That's my home graph, right? So put your little home graph on that first one, the parent graph, and I would like you to move it around nice and easy this way, please, if you would be so kind. Now, the correct way to do this is really left to right, right? So we're going to start over here and say, is it got a reflection? No. Is it being stretched or compressed? No. Is it being shifted to the left and right? It is. Is it being shifted up and down? It is. So I'm going to get a little clever here because I got the clever board happening. I'm going to move this guy 3, but remember, it's naughty, so it's going to go this way 3, 1, 2, 3, and then it's going to go down to 1, 2. If your bad boy looks something like this, there you go. And again, SAT, ACT, you're going to get a complex problem. You're going to be able to find that answer real quick without even plugging in anymore. Right? Okay, let's get a little weirder if you're ready. Let's try this. Let me put this guy back home again. I'd like you to try this one for me. Let's do y equals 3 times the quantity x minus 2 plus 4 minus, that's everything. Now I'm going to be honest. We're supposed to do the slope first and then move it around, but for most of us, it's easier to get your shifting done and then do the slope. When these get more complicated though, you guys, I'm gonna say to you, you have to do it in the right order. Today, we're okay. Yeah. So here I go. I'm going to go ahead and do this correctly. I am going to go ahead and grab this. Let's see. I'm going to go, I'm going to start them right here. I'm going to go up 1 over 3. So I'm going to go up 1 over 3. It's going to look something like that. And something like that. And then watch what's going to happen now. I'm going to move that red one around, right? So I'm going to get tricky here. I'm going to move it 2 this way. So 1, 2, and I'm going to move it 4 up. 1, 2, 3, 4. So here's what should happen. It should look like this red one. It should be really skinny, or pretty skinny, and it should be facing up like that. Yeah? Are we looking good? Okay. Next one. Boom. Let me get this out of here. Oh, I'll just get a new go. Okay, last one of these, and then we will, I'll do something weird. So try this. Y equals negative. Do I want to go hard? I do. I do. I do. I do. Well, minus 2, minus 3. There you go. So here's the first thing I know. Travis graphing this for me.
I am.
You are. We're going to flip him first off. You gotta flip this dude first. And then you'd make him pretty fat. And then you start shifting him around. But some people want to go ahead and do a slope first and then flip him. I'm okay with that. They're really, you can do it either way. So I'm going to go, let's see, 2, negative 3 is going to be down here. And then watch this. I'm going to go down 1 over 2. Boom. Down 1 over 2. How'd it look? You got it? You got it? You feeling good? Right? A little tricky on that slope on that guy. So what I did, remember the top number on the slope is always your up and down, and my bottom number is my side to side. So I went down 1 over 2, down 1 over 2. I'm good to go. I'm good to go. I got 2 last ones, and they're my favorites. And if you get a whiteboard pen out, if you got it, that way I can walk around and see how smart you are. Oh, God, let me get rid of it. Oh, now I got to go back and do another one. Okay, let's see if I can do it really quick. Oh, don't look. Okay, yeah. Okay, do you remember that other one? No, you don't remember. You don't remember. You're so confused. I'm confusing you. Okay, there we go. So there. Can you write the equation?
Write the equation?
Write the equation. Oh. Okay, please. Write the equation.
Is that it?
I think it is. Plus 5, yeah.
I don't need to put the negative 1, but I can.
You can. I like the negative 1. You don't have to put it, but you do need the negative. You do need the negative, but you don't need the 1. But if you have it, awesome. So a couple options here. Negative, definitely. You want to put a 1 there because the slope is 1. You can. You don't need to, though. It's up to you. I know I moved it that way, so that's going to be plus 3. And then I'm going to go plus 5. How'd I do? Did I do okay? Yeah? Okay. Last one, best one, little lambs. There you go. That is it for today. Tomorrow we start moving other things. Square roots, cubes, parabolas, all sorts of fun shapes. But they all work the same way. Want to know the shape? Who's calling me? Walgreens. He's pretty fat. So he's not.
Oh, you're right.
Yeah. X 1/3, X minus 1 plus 2. Yeah, that's it. Because here's what I did. To get to my next point, I went up 1 over 1, 2, 3. That's my stuff. Easy. Breaking our brains. That's it. I'm gonna check out that right. If you will get out the golden one. Oh, wait, hold on. It is y equals 1/3 times the absolute value of x minus 1 plus 2. Why COVID friends?